Okay guys, hello, I start recording for Amesim and I explain how to do the cooling system for the windmill. I will not complete all the exercise, but I will start it for you that you can follow it a bit. And I also want to mention this is the scientific version of LMS Amesim. You have the students version, so I have much more models here, but don't get confused. I will only use the terminal library. So you have this, you can open the terminal library, and we want to make a passive cooling system for Amesim. I make it a bit bigger. First, to start, if you start the exercise, you need to know that you have different metals. You have a steel generator core and you have an aluminum cooling system. So I take my first material here. This is a material for, let's say, aluminum coolers. And I need another system. I need another material. I take steel. Now it's both is aluminum, but I will one question. Can you hear me? Give me a thumb up if you can hear me. Hello, hello. One question. Can you hear me? Okay, I have to start the mic. Hello, is it better now? Can you hear me? Give me small thumb up if you can hear me. Okay, better. Okay, I start again the lecture. Here you see the Amesim. Please give me again a small feedback if you cannot hear anything. Yeah? Please give me short feedback. Give me thumb up if you can hear everything. Guys, give me small thumb up. Can you hear me? Okay. Again. No. Okay. So, is it better now? Is it better now? Can you hear me? Can you follow the lectures? Can you hear everything? Give me short feedback, please. Give me thumb up if you can hear me. Okay. Perfect. That is fine. Then I start again. At first, this is, I want to mention, this is the scientific version of Amesim, but it doesn't matter. It's the same as your student version, and we need to define materials. We have to tell the computer if we have iron or aluminum. And so I take the first solid data ball here on our model tree, and again another for steel. I will change it later to the definition. Then I need some masses for our generator part. I take this CT volume. This is now a model for our generator, yeah, for the core of the electric machine of the windmill. Then I take the next one. I take also an additional core. I need 3 altogether. can even take more, but I think 3 is enough now. This should be the elements for our windmill generator. And you might know it's like a big electric generator. You will have a lot of currents inside, and swirl currents and eddy currents, and this will cause heat. So you need additional heat conduction system here made from aluminium, and I place it. So let's take 3, and this should be our aluminium elements. I will change them later. This should be our steel elements. I will change them later. So now I have to connect them. They have to be connected. What Mrs. Seiler asked, how did you do that? What do you mean with how did you do that? This last 3 here, you can copy them, it doesn't matter. You can copy them, or I will delete them again. You take them just here from the terminal library. Here I look for them, and you just push them on the screen, or you can copy them, it doesn't matter. Yeah, I can also delete them. You can make a copy and copy them, it doesn't matter. And this is only an element for masses. Yeah, it's if you can have 5 kilogram mass or 10 kilogram mass, you can define it later. And then we say we want to have a heat conduction problem. We want to conduct heat, and I have to look for the model. Here is our conduction model. This is heat conduction. It's like this. I can again copy it, paste it here. And I can also rotate it. Delete it again. Copy it, paste it, rotate it, and I place it here. Here. So, yeah, it connects on its own, and now I connect them. And always, if the highlighting changes from brown to white, the connection is okay. So, and now these aluminium cooling elements, maybe I have also some nice pictures of these elements. We made this experiment with the company Innovind, and I can also copy you on the Moodle some pictures about this aluminium heat conductors, but maybe you also know them already from your computer or any other electric device. But we now need a wind velocity, and you have to take this element here. Wait a second. You take this element here, this you rotate it. It's already connected. You copy it, paste it, paste it. So, and now you need a source. You need a temperature source. You need an energy source and a power source. Yeah? Let's say a power source, and we take here this heat flow in watt, yeah? And we connect it only to the middle element. That's how I wanted to do it. You can also connect it to other elements, but the heat source should be here in this middle element. And now our model is nearly finished, but we have to close all these plugs where nothing is connected, and I copy them. So connect them. Okay, so our model is finished now. It looks good, everything is white and everything is connected in a good way. And now we have to compile the model. I go to compile. I go to, yeah, I have to save it first, and I save it here on okay. Don't forget to save it, that's really important. Okay, and now I go to the parameter mode, and now I can change the models a bit. First I have to change this. This is, for example, my material 2. It's a block of aluminium. Yeah, I define aluminium. And I want to change this one. This should not be aluminium. And please be careful. Solid type index, this is important. The type index, the solid type index has a number of 2. This means this is aluminium now. And if I go to the first solid type, I don't want to use aluminium. I want to change it. You can have a lot of different metals. And let's take this is a good metal, plain carbon steel. Okay, this is a good metal for the core of our generator. And now this is solid type 1 and this is solid type 2, and now I must tell my masses which solid they should be. I go to the first. This is solid type 1. This is steel. This is again steel. This is again steel. And here I can change this to aluminium. Okay. And here at the top you can change the wind velocity. Now we have 2 meters per second. We can change it to 5 meters per second. This. Okay. And here we have our conduction problem, and that's something you should change on your own. Yeah, please look to the exercise. You should change this to the conduction values of steel and aluminium, and here we can define the heat source. Let's say we have 250 watt waste heat, and more or less this first example is finished. And let's make the first simulations, recompile it. Okay, maybe we can change the time a bit, final time, make it a bit longer. Okay, so the simulation is finished, and now look how hot our material gets. Okay, this is pretty too much. 700 degrees centigrade, it's a lot, it's much too much. Yeah. Okay, if I make the, because our system is pretty small, yeah, maybe I make 10 watt. It's a small heat conduction system. Of course, at a windmill it's much bigger. Yeah. Okay. So, did you get an idea on how to do it? Mrs. Seiler, is this okay for you? If you agree, we can quit it here, and you can start doing the example with your own values, with your own, for the big system, for the big windmill. Okay, maybe watch it again. Of course, all these values for geometry and for fluid flow and also this conduction connections, you have to change the values here a bit for the surface to get temperatures lower than 100 degrees. Now we are at a really high degree. If you have a lot of power, electric heating power here, if we have too much, if we have 100 watts, we get the temperature will be too high for our generator. Yeah, we will have 400 degrees, and the iron and the aluminium will start deform, or aluminium will be damaged. The structure will be damaged. It will be much too hot. We will get first steps in plastic deformation, so the whole windmill will be damaged. You have to cool down the windmill until the temperature is below 100 degrees to prevent plastic deformation of the windmill generator. Okay, I think this is enough help now. I will copy you the movie into the Fluid Energy Machines Moodle, and you can follow it later. Okay, I've finished the movie.